B. Could a person walk across the U.S. in a year? Well, some of you aren't real good at estimating, and so you know that the United States looks something like that. You know, Washington, something like this. So, how many Washingtons is it across the U.S.? Less than 10, right? So, if we figure out how long it might take somebody to walk across Washington, we might have an idea how long it takes somebody to walk across the U.S. It'd be 10 times longer. Should do it. So, do we know anything about Washington? Well, from Cle Elum, or from Ellensburg actually, to Spokane. And for those of you who don't know, Spokane is real close there, and Ellensburg or Cle Elum is close to the middle of the state, is 300 miles. So across the state is 600 miles. So across the U.S., it looks like there's 6, 7, or 8 Washingtons you get across. Let's just say it's 8. 600 miles across Washington times 8 Washingtons get you across the country. That's 4,800 miles. Actually, from the coast here to New York is about 3,500-ish. So that's not a bad estimate for how many miles you'd have to walk. Now, how far can you walk in a day? Well, if you're on a hike, 10 miles, 15 miles is a good hike in the mountains. If you're walking on the road, you might be able to go 20 miles. For ease of calculation, let's just say 20 miles per day. And we got that many miles to go, so let's take this divided by 20 miles in a day. That means it's 240 days. What if you only walk 15 miles? 4,800 divided by 15, that's 320 days. It's 365 days in a year, so you'd still make it. So, could a person walk across the U.S. in a year? Yes. In fact, some do it in maybe 4 months or 5 months. It's about 2,000 miles to walk the crest from Mexico to Canada. It's called the Pacific Crest Trail, the PCT. And people do that in about 3 months, and it's about 2,000 miles. It's about twice as long this way. If they can do that in 3 months, they can do this in 6 months. And this is flatter out here, so probably less than 6 months. Okay. 49. 2 centimeters on a map. 1 centimeter, 2 centimeters. This distance on a map represents 100 kilometers. So they want you to get a scale factor. So it means you want to get rid of the units. So if we put 2 centimeters and 100 kilometers, what we want to do is change the 100 kilometers to centimeters. So to do that, 1 kilometer, putting it in the denominator so the kilometers cancel, 1 kilometer is 1,000 meters. And then a meter, 1 meter is 100 centimeters. So we have 100 times 100 times 1,000, which is 10 million centimeters. So the scale factor is 2 centimeters is equal to 10 million centimeters in real life. The centimeters cancel, so you got a scale factor of 2 to 10 million, but it's usually done as 1 to what? So if we reduce this fraction by dividing the numerator by 2 and the denominator by 2, so one length on the map is 5 million times bigger in real life. So if there was an inch on the map, in real life, it would be 5 million inches. That's what a scale factor means. No units, so you have to get the units to match. So if they say a half an inch on a map is 1 kilometer, then we have to convert kilometers to inches so that they got the same units. So 1 kilometer, let's see, how do we do inches? Well, 1 kilometer is 1,000 meters. And in a meter, 1 meter is about 39 inches. Because a meter is a meter stick. A meter is 3 feet or 36 inches. A yard is. A meter stick is slightly longer. It's 39 inches-ish. You can Google it and get a little bit closer, but that's close enough. So if we actually have a kilometer, we have 1,000 times 39, 39,000 inches. Because the meters cancel, kilometers cancel, we get inches. 1 times 1,000 times 39 divided by 1 times 1. So now the inches will cancel and we can get our scale factor. But we usually like to have a 1 here. Well, this is a half, so if we multiply by 2, that will make it 1. So we have to multiply this by 2. And our scale factor is 1 unit on the map. Inches, centimeters, whatever, will be 2 times this is, let's just show you, 39,000 times 2 is 78,000 on the map, or in real life. So 1 inch is 78,000 inches. 1 mile is 78,000 miles in real life. But your map wouldn't have 1 mile on it. The map has to fit in a room somehow. Okay, the universal clock one. So I've done this different ways. I'll try to do one that might make most sense for you folks. So, excuse me. If it's 4.5 billion, so 4 comma 500 million 0 thousands and 0 in the 1, so this would get us to thousands, get us to millions, get us to billions. 4.5 billion years is 24 hours. That's 24 hours. So if we take this and divide it by the 24, we find out how many years makes 1 hour. So we take 4, 4500,000,000 divided by 12. So in Earth, the time on Earth would be 375,000,000 years is what 1 hour on the clock would be. Well, what they want us to get, they said, what would be a billion years? Well, a billion is just like 4.5, this divided by 4.5. So you take 24 hours divided by 4.5, and that will tell you how much 1 hour is. And so that would be, let's see, 24, how much 1 billion years would be. 24 divided by 4.5 is 5.1 hours. So this is 4.5 billion. So if you divide this by 4.5, you'll find out that that gets it to 1 billion years is 5.1 hours. But human history was 10,000 years, and this is way more than 10,000. To get this down to 10,000, we have to divide it by a big number here, by this amount. So let me point how that would work out. So if I want this to be 10,000, if I take that number, 375,000,000, and divide it by 10,000, that's the number I have to divide into this to get 10,000. So I have to take an hour and divide it by 37500. 1 hour is this many years. I think I said that wrong. Is let me say that again. Nope. I want to get this to 10,000. So I got to take the time it would be 137,500 hours. That's what I want to say. To get this to be 10,000, I have to divide it by 37500 to get this to come out to be 10,000. So I have to, the amount of time would be 1 hour divided by that. Well, that's a really small fraction. So let's convert this fraction to minutes. So I want the hours to cancel, and I want minutes. So that's 60 minutes is 1 hour. So if I do that, 60 divided by 37500, I get that fraction of that many minutes, 0.0016 minutes. Well, that's pretty small. I wonder how many seconds that is. So 1 minute is 60 seconds. And so I multiply by 60. And so it's less than a second. It's 0.096 seconds, which it rounds off to about 1/10 of a second. So a second is 1001. So a tenth would be 1. So boop. So if the Earth is really 4.5 billion years old. And we start the clock there when the Earth formed, and by 12 hours later, we're at present day. Then the Earth happens, and it goes clear around 12, 11:59 and 59 seconds, 11:59 and 9/10 of a second, and then boop, that last little bit is how long humans have been there in terms of the human lifetime relative to the Earth. 1/10 of a second ish. So that's the answer to 56.